Hi everyone. Proportions video today. So you've already gone through the quiz for this, and it's the last reading that we had for this semester. We include this chapter not because it's crucial to the bigger picture, but it's the last piece of information that you really need to do your term projects, at least in terms of the demographic data. So I'm going to talk just very briefly a little tiny bit about proportions in general, and then show you what to do in Jamovi to get the confidence intervals that you're going to need for your term projects. So just briefly going to go through a few slides here from chapter 13 of the textbook. And it starts out talking about frequencies a little bit. And this is something that we have talked about before, right? Whenever we've looked at histograms, we've been looking at the frequency of different responses, usually from a Likert scale. So this kind of fake data on the left here, right, would be the number of people that responded to each level of this Likert scale from strongly disagree to strongly agree, right? And frequencies is telling us, right, how many people selected each of those levels, on ordinal data like this. But we can also use frequencies to talk about nominal data here if we're looking at preferences for flavors of ice cream. Now, I or you may believe that certain flavors of ice cream are better than others, but there's really no difference in those values, right? They're just telling us how many people selected these different flavors of ice cream. And when we talk about nominal data, right, we can't run most of the statistics that we like to run on nominal data, but frequencies and proportions are where we can actually categorize and get some numerical information for that type of data. And proportions are relatively intuitive for most of us, right? It's basically just the number of whatever frequency we're talking about divided by the total n for that study or the people that you are referring to, right? And capital P means proportion, right? So if you see little p and recognize that as p-values, this is a capital P, so that stands for proportion, italicized like all of our statistical representations are, right? And again, right, you probably already know how to think about this. If you have a 20 question test, so then in that case, n is 20, and you get 17 questions right, 17 out of 20, the proportion is 0.85 or 85%, right? If you move that decimal place over 2, it represents percentages, right? But proportions are always presented on that scale from 0 to 1, right? Because x is always between 0 and n, so we get on that scale. And one more example of where this might be used, because this will come up on the homework assignment for proportions that is due. It's a little bit of time before then, right? But you can come back to this if you need to. But this is where proportions come into really big usage in the research world, right? So this is some example data. This is a shortened version of the slide set that you have access to on Canvas, right? But this particular study, which is now over 20 years old, was looking at why people in Mediterranean countries tend to have lower rates of heart disease and cancer, right? People were trying to understand, is this genetics? Is it diet? What's going on? And so one thing they investigated was whether a Mediterranean diet had any effect on rates of these diseases. And so they took 605 patients and assigned them to either a Mediterranean diet or a control diet for 4 years, right? So this is a long-lasting kind of study. And so they kept track. One of the pieces of data that they had are just basically frequencies showing the cancer and cardiac death rates from this group of 605 patients, right? So if you look at A here, we're looking at cancer. And so they have everyone on the control diet, everyone on the Mediterranean diet, right? And then how many people in the control group died of cancer versus did not have cancer, right? And then in the Mediterranean diet, cancer versus no cancer, right? And so if we want to compare here, we're really comparing the proportions of the control group and the Mediterranean diet group. So if we look at the control group, 17 of the 303 total control patients were diagnosed with cancer, versus the Mediterranean diet, 7 of the 302 total Mediterranean diet patients were diagnosed with cancer, right? And so those proportions are 0.056 compared to 0.023, right? So percentage points, right, if you want to convert that in your head, we're talking 5.6% of the control group, but only 2.3% of the Mediterranean diet group, right? So that's enough where if we look at the difference and the confidence interval on that difference, it doesn't cross zero. It seems like maybe there is an effect of the Mediterranean diet on health. They also looked at cardiac disease as well, and we see similar differences here, where 19 of the 303 died of cardiac disease or cardiac-related illnesses in the control group, but only 6 of 302 in the Mediterranean diet group, right? So that's that way that you can use that kind of comparison on a frequency table, right? So you'll do some of this type of kind of math and analysis on the proportions homework that's coming up. But the other thing I want to show you, because ultimately the most important thing that you're going to use proportions for the rest of the semester is to present your demographic data in your term projects, right? So I made up some kind of fake data here with the 3 demographic variables that all the groups have. Some of you also had class year, right? But you would consider that a nominal variable as well, right? And so I included age here just to remind you that when you're presenting the age of your sample, right, you would run a mean and get mean and standard deviation and a confidence interval on the mean for that, right? Age is ratio data, so even though it's a demographic variable, you can report it the same way that you would any type of ratio data. You're just going to be including that with the demographics. Gender and race, though, we can run and get proportions and compare those proportions to the Dominican population itself. You can compare the age to Dominican as well, but again, you're just going to be using kind of stats that we've already done for that. But let's take a look at how to look at gender and race and other nominal types of variables that you might want to get proportions for. So for this, the easiest thing to do is a combination of PSYC and one of the other options. So this is one of the few times during the semester that we step out of PSYC in Jamovi and actually use some of the other Jamovi tools. And so what I suggest that you do for this is to go to frequencies first. So if you click on the option, this is something that's just built into Jamovi. It's not a separate module that you have to install. And you can just use this 2 outcomes. You're not actually running a test, you're just getting numbers at this point, but this is kind of the easiest and quickest way to do this, right? So let's look at gender first, because this is pretty straightforward, right? And we can actually get most of the information we want right here. So we get, for gender, females and males, total count, right? Get our proportion, so 0.833 for female and 0.167 for male. And then we even get our confidence intervals there as well, right? So that's pretty easy. If you did want to go over to PSYC, you can use this information and get some of the figures. Now, you don't really need figures necessarily for your papers. Having the numbers themselves either in a simple table or actually in the body of your text is fine. But you could, right, kind of get figures from PSYC like this, right? So if we wanted to get one for females, right, we have 55 out of 66 in this case. And it's not working. That's always fun. Oh, it's because I didn't enter summary data. See, this is why these are useful. So because you have information, you can enter the summary data there. So 55 and 66, and you'll get kind of a nice graph of the proportion that you put in, but you'd have to do a separate one for each category. So you'd have one for females, one for males. And so I don't recommend making a figure for that for your paper. But if you ever need a figure for proportions, you can get a nice one from PSYC, right? But let's go back to frequencies. So we took a look at gender, but you can do the same thing for race, and it will break down with all the different groups depending on how people responded in your study. And if you ask for confidence intervals, you'll get those there as well. All right, so in this case, in this data, have 5 different groups that came out, right? So that's not all the categories, for example, that you would have had, and it's likely that you'll have some categories with nobody represented in your groups as well. Some of your samples were smaller than others, right? But in this little mock 66 group, right, 45 of the 66 were Hispanic Latino, right? Proportion of 0.682 and a confidence interval there, right? And smaller members of the other groups. So I have included on Canvas a data file that has the DU student breakdown from 2018. So it's a couple years old, but you can use it for this purpose. And part of what I want you to do as you present the demographics of your sample in the participant section of methods is to compare your sample to the DU population, right? And so how you do that is using the confidence intervals on the proportions that you get. So let's say you wanted to say whether or not your sample was representative in terms of gender for the DU population, right? So in our little fake sample here, we have 0.833 proportion of females and 0.167 proportion of males. Now let's say you open up that data file and 68% of Dominican students are female. In that case, we would say that our sample overestimates the proportion of females in the Dominican student population. Why I say that is because that 68%, which would be a proportion of 0.68, would be outside of the confidence interval on our estimation of the proportion, right? So if that confidence interval captures the actual DU proportion, then our sample is reasonably representative. But if it's not, if the DU number is outside of that confidence interval, then you would have to say that we didn't quite represent the population well, right? In that case, if the actual female proportion was 0.68, right, then we're overestimating females based on the sample that we have. And you can do the similar analysis there with race, right? So for each category, right, you can compare the proportion, right, from your sample with that confidence interval to the Dominican University numbers themselves and say whether or not your sample is representative. You can do that for age as well. You will have an average age of Dominican undergrad students, and if your confidence interval on age, the mean for age, captures that Dominican number, then we're representative there as well. So that's the kind of information that you want to put in the demographics section under participants in methods, right? So this is why we kind of introduce proportions at this point. Other than that, I don't want you to worry too much. You will have the homework assignment on proportions. It's not something that we're going to have on the final exam. So this is the extent of what you need for proportions. And that is standard. We don't usually test you on proportions for the final. The last kind of key bit for the final was the regression that we had on top of correlations. So heading into the final exam, right, you're going to continue to practice the skills that we've been working on over the last couple months. And so, you know, reinforcing those skills by doing the data analysis for your term project is also helping you prepare for the final exam as well. So if you have any questions about proportions, please post them on the discussion board, or if you have questions about what I walked through here. Sometimes it's not intuitive until you start to think about it a little more. Please post questions or send me an email. I'm happy to go through this more or provide more information on proportions, but this should cover the basics that you need to succeed in doing the analysis you need for your term projects. All right. It was good to see all of you this week in our little group meetings for your projects. I'm glad that for the most part, you're all hanging in there. Please let me know if there's anything I can do to help for class, or if there's anything I can do outside of class if things are happening at the university. Myself and the entire psych department is always here, so please let us know. Be safe, be well, and I'll talk to you again soon.